I want to discuss a little bit about color, really as it relates to the technology of it. You'll probably get a lot of coursework on color theory and ways to manipulate it. And I really want to just kind of focus on this idea about color and the way our computers use it, the way our printers use it. So you have a little background on kind of manipulating it, mostly to kind of help coordinate and create consistency across the projects and workflow that you'll do. So we have some basic ways of describing color. We have a CMYK, cyan, magenta, yellow, and black. We have red, green, and blue systems. And we have HSB, which are hue, saturation, and brightness, I believe it is. The two that we'll primarily deal with are red, green, and blue. They're additive colors. You combine them together, you get white. Cyan, magenta, yellow, and black are considered subtractive colors. They have this idea of a transparency, and when they're all combined, they're actually subtracting color from each other, and so you get black as the combination of them. The distinction here for us is that we work in a red, green, blue space. When we're dealing with our monitors, the digital outputs, the pixels are in the RGB color space. The CMYK color space, though, is what we use when we print things out. And that's where this idea of understanding the two systems and why it will be important for you to understand that to get consistent output. So these are just a graphic of on the right here of CMYK colors into a printer: magenta, cyan, yellow, and then this large one over here is black. The reason why we put black in our printers and don't just combine the three colors is the idea of creating a really rich black. Otherwise, if we combined just the mechanics of color, of combining these colors, the three colors combined would kind of create a kind of a muted light or dark gray. And so we typically add black to our printers. And like I said, our monitors work in RGB. You can call it RGB color space. And so here we have a monitor. If we looked at that monitor up close, here we have two different levels of zoom in of that, but you can actually see the red, the green, and the blue pixels. And when they're all on together, we get this illusion of white, a white background. And we can turn pixels on and off to create any kind of color variation we want. And the technical connection to this for us and our software is that we actually have the adjustments of red, green, and blue. And I'm finding this is saying, it's not saying the RGB colors in a way that's necessarily completely clear here. So I want to go to the next, hopefully the next slide here. I'll talk about it here and then probably expand in a later slide. The red, green, and blue are numbers that go from 0 to 264. That's 8-bit. That's 8-bit data according to computer speak. So if you wanted something to be completely red, it would go up to 256, I believe it is, not 64. I'm sorry. And it would be totally red. If you wanted something to be totally black, all of these would be up at 256. If you wanted something to be totally white, they would all be set to 0. So just to start for your understanding of how you manipulate that. And once again, why this color matters. We see something on the screen. We want it to have great fidelity when we print it over here, and we can be really surprised by the fact that we've gone through this transition from an RGB color space with a monitor that has a light behind it to printing on paper, which doesn't have a light behind it, and printing with a different kind of color fidelity. So one of the things, one of the cautions here is to understand that will happen, and then to make small printouts of your graphics before you go to the final versions, because you may desire to make modifications to how it looks on the screen to get it to look better on a computer printout. Another system that we have within the software is this HSB, hue, saturation, and brightness. That's another set of controls over here. And this is, if we were to click into this to go to our color picker, and this shows up in things like software like Adobe Illustrator. Here we have a full gamut of the selection tools that are available to us. So the world of HSBC is kind of, HSB is actually kind of useful because you get this nice rich graphic. You pick a color green, you can make the green lighter or darker by changing one number. If you wanted to change a color in RGB color space, you'd have to know how to manipulate each 3 numbers individually in order to just make something brighter or darker. So there are times when this color space might be more useful to you. I know that's a lot to throw out. I just really, the really important part of this lecture is to make connections to the world of color that you may be concerned of, and then how you have manipulations within inside of your software. And we actually have some really powerful tools, even within inside of our BIM modeler, that surprise me. If you'll notice, there's a button that's called Pantone. Pantone is called a color matching system. They have established this kind of like high fidelity between what gets printed out or a paint chip might look like and what you might set it for numerically on side of your computer. So even if it doesn't look right on your computer screen, if you specify a Pantone color, you'll have a physical chip, a paint, a swatch of paper that you can look at, and you can be guaranteed that if you specify, or guaranteed as much as you can with anything about color fidelity, that if you specify that color, you can literally show somebody a chip of a painted piece of paper or printed piece of paper to the exact color that you want to match. So Pantone is an industry standard for color matching systems, and something that is available to us within inside of our modeling software. And color matters a lot. At this point, I just want to introduce this idea that a color marketing group is established that makes determinations of color years out in advance of trends of what people are interested in contemporary design and with respect to color. And that affects the way our fabrics get printed, our paints get developed, our products get colored, and they have a real huge social influence on us. Color is very impactful for making us evoke feelings of trends and things that are happening in the world. And so to be aware of this, you can click through to the color marketing group. And there are other ways that we kind of tangentially make contact with color when we're specifying our building materials. So here, very common to walk into a paint store, right, and be provided with a huge array of color samples. And we know when we're talking about, one of the places where we really understand that color is absolutely critical is in interior paint colors. If you've had any experience with trying to pick something out or match something. But those ideas of color and the fidelity of color are fit out to all of our exterior building materials also, from colors of brick to colors of metal panels and trim systems that we might use. So color is something you'll obviously become increasingly more aware of in your architectural education. I just want you to have a grip on the idea that we have software control about the way we define it. Pixels and resolution. I wanted to take a minute because this is an ongoing trend. Our computer monitors are getting sharper and sharper. The amount of pixel or pixel density continues to go up. And I think it's important you have this idea about what a pixel is. When we look at our high resolution phone screens, it almost looks like there's nothing actually creating the image. It's just high sharpness all across it. But if you were to actually zoom in very close, as a matter of fact, if you have your phone and you've ever gotten a drop of water on it, you'll get this effect of magnifying the screen, and you'll be able to actually see these kind of pixelations of our screen. This is usually not any longer available to the unaided eye to be able to see the pixels on our screen because the resolution is so high that it almost, it seemingly disappears. As a matter of fact, Apple has coined the term a retina display, which means the resolution of the screen that you're looking at is as high as your eye can resolve, so to speak. So you can't see the difference between pixels because they're so small and close to each other. But we're still based on this idea that everything is created with these pixels. And it's important that we're kind of aware of that. And I'll save this for an in-person lecture.